Hello, welcome back. In this segment, we're going to look at loops or repetition in Java, and we're going to look at the three most common ones: the while loop, the do-while loop, and the for loop. There is one more loop in Java that we won't cover in this video. It's called the enhanced for loop, and it has to be covered later in the semester when we look at arrays. So let's start out by looking at the while loop. Well, just before we do that, remind you that up until now we have talked about sequence and selection, and these are the three control constructs in structured programming: sequence, selection, and repetition. Sequence is too simple to even talk about it. You start at the top and execute the lines of code in order from top to bottom, and selection is where you selectively execute some lines of code with if or switch, and repetition is what we're going to do in this video. So we have a while loop to start off with, and the while loop, the general form is you have the keyword while and then you have a condition which must evaluate to a Boolean. So this is exactly the same syntax. This is exactly the same syntax as we had for the if statement, except we have the keyword while there. So look at this code down here at the bottom. We have a code snippet with a while loop in it. So we have a counter variable, and it's initialized to 1. When you're looking at what these loops do, here's what I recommend you to do, and here's what you'll be asked to do on a test, for example, a midterm test. Write down the names of the variables that you have and the word output to keep track of what this program is doing. So every time you execute a line of code, write down on this table what's actually happening in the variables and what the program outputs. So this is the simplest possible loop construct, and we're going to first of all initialize the count variable to 1. So we'll write 1 on the table over here underneath the variable count, and then the arrow on the left will point at the line of code that's going to execute next. So now we evaluate this condition. Count is less than or equal to 5. Well, you look over here and you say, yes, that's true. Count is 1, and that's less than or equal to 5, so we're going in to execute the body of the loop. And we do a system out print line and output the message count has 1, and then increment the count variable. So we write down under count that it now has 2 in it, and when you come to the bottom of a loop you go back up to the top and evaluate the condition again. So now we have 2 is less than or equal to 5, and that's true, so we're going into the loop and we're going to output count has 2 and increment the count. Now it has 3, and keep going. Output the message. We write it down on the little table. Increment the count. And as you're walking through this, one line of code executes at a time. So each line of code is not that difficult, and you can keep track of what's going on. If you look at the whole thing, it might start to be difficult. So look at one line of code at a time and execute it as if you were the machine. So when we get here, the count increments to 6. And we go back up to the top and we say 6 is less than or equal to 5, and this condition is false. So the loop is over, and we would continue executing the code after the body of the loop. Okay. So here is your first loop in Java. It's a while loop, and execute one line of code at a time and see what it does, and it's not that difficult. Okay, so here are some examples for you to practice with. Output the multiples of 5 less than 100. And then output the even numbers in descending order from 70 to 50 inclusive. Sum the numbers from 1 to 100 and output the results. When you're trying to write a loop that meets some problem statement like these three that are given here, you think of three things that will control the loop. Where does the loop start? Where does it stop? And how do you get there? So think of the first one, output multiples of 5 less than 100. So the starting place has something to do with 5. The stopping place has something to do with less than 100. And how do you get there? Well, the multiples of 5 are 5, 10, 15, 20. So we're going to add 5 to the counter each time. So this is still a counter-controlled loop, even though it doesn't count by ones, it can count by 5s. So think of the second one. Where do you start? Where do you stop? And how do you get there? The third one is a little more interesting because it has not only a counter variable but an accumulator variable. So you're going to sum the numbers from 1 to 100. So you start at 1, you end at 100, and each time through the loop you're going to use an accumulator variable to throw the counter into a bucket. So it looks like a plus gets might be appropriate there. And I'm not going to solve all of them. I'll show you a solution to the third one, which has both counter variables and accumulator variables. So where do you start? Where count is equal to 1. And we have a sum variable that we initialize to 0. And then where do you stop? While count is less than or equal to 100, keep going. So keep going and stopping are kind of the opposite of the same thing. And each time through the loop, throw the count into the bucket. And until you get used to it, you can expand that. Sum plus gets count is the same as the old sum plus count goes into the variable sum. You have to be careful that sum was initialized to 0, because the first time you use it would be here, 0 plus 1. And if you don't have a value in sum, it won't compile. And then the how do you get there? You're going to get there in steps of 1. So walk through this a little bit and see if it seems to be working. So I want to talk about a sentinel-controlled loop. This is as opposed to a counter-controlled loop. In the previous examples, we looked at loops where a counter variable would decide when we should stop. And a sentinel-controlled loop, it uses a specific value called a sentinel. And the sentinel value is not data. So here's the specification where we could use a sentinel-controlled loop. Ask the user to enter some test scores, and when they've entered all the scores, they will enter the value -1. So -1 is the sentinel value. It couldn't possibly be a test score. No one scores a negative number, I hope. And this program will sum up all of the scores entered and output the result. Well, this one is difficult enough so that I want you to see a solution to it in Eclipse. So here's the spec. We're going to ask for test scores using a sentinel-controlled loop, and we're going to sum up all of the scores entered and output the result. So let's go over to Eclipse. And I've started to solve this problem already. So I've made an object of type keyboard that we'll use to input things from the keyboard. And I've declared a variable called grade. I think it maybe should have been called score to match the spec, but that's okay. Now let's declare the sum and initialize it to 0. So in a sentinel-controlled loop, here's the pattern that we use. We ask for the first value and read it in from the user, and then we go into the loop and say while it's not the sentinel value. So if the very first one that they entered was the sentinel value, the sum will remain as 0. But if it's not the sentinel value, then we're going to add it into the accumulator. And then what we're going to do is we're going to, at the bottom of the loop, repeat those two lines of code. So I'm going to copy paste them here, and we'll ask for the next one. So here's the behavior of the sentinel controlled loop. The priming read, the read before the loop starts, then check for the sentinel value, then process the valid data. So if we get here, we're processing a valid grade, meaning it's not the sentinel value. We're not adding -1. And then ask for the next one. The first thing that we do after we get the next value is we check and see if it's the sentinel. So when the user enters -1, this loop is over because not equal to -1 will be false. So the spec also said output the sum. And I'm not sure if I got this correct. The first time I write code, well, I'm not really sure. So let's just try and run it and see what happens. Enter a grade. So if I say 100, enter a grade, 90, enter a grade, -1, the sum is 190. So we added up the valid grades, but we didn't add in the -1. And this loop will go as many times as you want. So this is the key factor in a sentinel controlled loop. You don't know how much data you have, so the user can just keep entering until they decide that the loop is over by entering the sentinel value. Okay, I'm going to set a no, I won't bother to set a breakpoint, but I'll encourage you to, when you're creating your loops, and if they don't do what you expect them to do, then the fastest way to get them working is to set a breakpoint and watch them execute. A lot of times what you think you've typed is not exactly what you've typed. So the machine doesn't do what you want it to do, it does what you told it to do. Okay, let's go back to the slides. So we've talked about the sentinel controlled loop. So that was the while loop that we've talked about up until now. And it's called a pre-test loop because you test for the stop condition before you go into the body of the loop. All modern languages, including Java, have something called a post-test loop. And here's the post-test loop in Java. It's a do-while. So this is about the only time, there's one more exception, but it's very rare to put something on the same line as a close brace. And you're allowed to do that in a do-while because if this were on a line by itself, it would look like a while loop with a semicolon at the end, which wouldn't make any sense at all. So this is the general format, and this loop does exactly the same as this loop. And it might not appear to. Do-while loops are really not favored in industry, and you should use them sparingly. It's difficult to read them and understand the behavior, and sometimes you have to scroll down to see the stop condition and then back up, and that wastes people's time. So the difference between a pre-test and a post-test loop. A post-test loop, a do-while, always executes the body of the loop at least once. There's nothing at the top to stop it from going into the body of the loop. A while loop, on the other hand, might execute 0 times if the condition is false the very first time. So you do have places where a do-while loop is a good choice, but not very much. Okay, we're going to look at the for loop. And the for loop is used for counter-controlled loops. At first it's a little bit harder to read, but once you get used to it, it's your loop of choice for counter-controlled loops. So the general form here, you have the keyword for and the parens and 2 semicolons. This is minimum requirement for this to compile. You must have exactly 2 semicolons here. And here's an example of a while loop that was a counter loop, and we're going to translate this into a for loop. So where you start is expression 1, and in Java you can declare your variables wherever you want, including in expression 1 of the for loop. So this variable count is being declared in the for loop specifically for use only within this scope. That variable will go away when the for loop is over. So an initializer, which happens only once, as if it were outside the loop. And then a condition which must be true to enter the loop. And then expression 3 is almost always used to change the control variable. So this is the how do you get there. The tricky part about the for loop when you're just getting started is that all 3 of these things are on one line, but they don't all happen at the same time. So the control variable incrementer, or expression 3, happens as if it were on a line by itself down at the bottom, just like it is over here in the while loop. So it happens after the body of the loop, even though it's on the line of code before the body of the loop. So here's the order of execution. We come and do expression 1 one time. And then we test the condition. It must evaluate to a Boolean. If it's true, we're going in. After we've done the body of the loop, then we're going to do expression 3 down here at the bottom, go back up to the top, and do expression 2 to see if we do the repetition. So we do this only once, we do this before we enter the body of the loop, and we do this, expression 3, after the body of the loop. Each time go back up to the top and test the condition. So there's the behavior of the for loop, and it's easier to use a for loop because once you get used to it, you look at one line of code and see the entire behavior of the counter-controlled loop, the start, the stop, and getting there. Okay, just in summary for these loops, we have now talked about all of the control constructs in structured programming: sequence, selection, and repetition. We looked at 2 kinds of loops, the counter-controlled loop and the sentinel-controlled loop. And when you're writing your code that has repetition in it, as you're getting started doing this, it can be a little bit tricky, but think about where do you start, where do you stop, and how do you get there. And that's how you can, that's how you can get your loop to work the way you want it to. Counter variables and accumulator variables, that's not their data type. Their data type might be ints for counters, and it might be ints or doubles for accumulators. It's what they're used for. And to get your loop to work, use the debugger. Watch what it does instead of what you think it does. So we looked at the while loop, which is a pre-test loop, and it's often used for sentinel-controlled loops. We looked at the do-while loop, which is a post-test loop, and it's generally frowned upon, but it might be useful once in a while. And then we looked at the for loop, which is used for counter-controlled loops, and it's very common, so we're all going to have to get used to using the for loop. But we'll use the while for counter-controlled loops. And I mentioned that we have this other one called the enhanced for loop, but we're not going to do it in this segment because we need to work with arrays when we're talking about enhanced. So there are the 3 loops, and we can now start solving problems that involve repetition.